Hello everyone, welcome to CSE Core Concepts in the series of data structures. Precisely we are talking about tree type of a data structure. In my earlier video, I have discussed about the various parameters of tree such as the height and depth of the tree, in degree and out degree of the tree. In case you have missed my earlier video, please go through the different parameters about a tree. In this video, we are going to discuss about the traversal in case of a binary tree. But before we can actually discuss about the different types of traversal in the binary tree, let me first explain you about how do we get an tree form from an arithmetic expression. Consider this arithmetic expression v1 multiplied by v2 minus, in bracket we have v3 plus v4 exponent to v5. Now first we are going to divide the tree into two parts. One part is the bracket part after the bracket part and another is before the part. So the operator which is dividing it is the subtraction. So let us consider it as a root node. Now on the left hand side we have one sub equation, and on the right side we have the another equation. Now if you analyze the equation properly, we can see that it is v4 exponent to v5. So here we again divide the equation into two parts, that is sub addition. So v3 is added to the result which we get after performing v4 raised to the power v5. And on the left hand side of the tree we have the v1 multiplied by v2. This is how we can create the representation of the tree using for an arithmetic expression. Now traversing in a binary tree means that visiting every node in the tree exactly once and in a proper manner, in a systematic manner. Now there are three types of traversal. One is a pre-ordered traversal, in which the root node is traversed first, then we move on to the left side of the tree and then to the right side. Now here you can see two words recursive in case of left and right, which means that when you are traversing the left subtree from the root node, that the left subtree might also have other subtrees. So you are going to traverse all the left nodes and then you will traverse the right nodes. Similarly, when you traverse the first subtree to the right node, in that again you have to follow the same traversal pattern, that is root left and right. Hence it is a recursive function. So let us consider this tree, that is ABC. We have two left and right. Now say for example I want to perform a pre-ordered traversal of this tree. Now in this case what I will do, first I will since it is a pre-order, so root is at the beginning. So first element which is there is the A. Then I will go to the left hand side. Now in the left hand side B, this subtree is there B. Now B has again branches, right? So if B has again branches, so B is the root node of that branch, so B will be traversed, and then again you proceed to the left hand side, that is C. Now since C does not have any other more further branches, the third element is C, and after that we again return back to the root node. So root A has been traversed, A is traversed, the left portion of the root node, that is B and C, have been traversed. So now we will go and visit the right portion. So in the right portion we first encounter D. Now D is again a root node because it is further divided, as it has further some branches. So in this case after traversing D, we will go to the left side of D, because again it is a subtree. Now how will the traversal be done? Left. So first we will go to the left side, that is E. Now E also has a further branch. So after E we are going to move to the E is the root node, so we will of course visit it and then go to the left hand side of that E. But E does not have any node on the left side, but it has on the right side. So root E has been traversed, left side is traversed. Since there are no elements, we skip it. Now we go to the right side is F. So the next node which we visit is F. Then we again go back to our root node, that is D, because the right side traversal is remaining. So now we will go to the right side, that is G. So here if I want to if I want to traverse this tree using a pre-ordered traversal, it goes as A, B, C, D, E, F and G. This is how we perform a pre-order traversal. Now you can go for a post-order traversal, where in case of post-order traversal the route is visited at the end. So consider the same binary tree. So first you will go to the left side. Now when you start from the root element, you go to the left side B. B has again left element, so you will again go to the left side. So you will traverse finally to C first, because after C there are no further branches. So C will be visited first. Now you come back because this subtree B and C does not have any right branch. If it had a right branch, then we would have visited that right branch. But since it does not have, we will go to its root element. So who is its root element? B. Okay. Then again B does not have any right branch. So we will go back to its root element, that is A. Fine. Now A will not be traversed because root will be traversed at the end. Okay. So we will not visit A, but we will go on the right hand side of A. Now right hand branch of the A is D. Fine. But it is again a subtree, because D we will again move to its subtree from the left side. Okay. So D's left is E. Fine. Okay. So E has again sub branches, right? So we will go to its sub branch, that is E. E does not has any left branch. E is a root node, right? So E does not have any left branch. Okay, but we will move to its right branch, that is F. Then we will again come back to root node, that is E. So that element will be traversed. Again go back to your root element, that is D. Okay, but D is a root which has a right branch. So we will first traverse that right branch G, then we will visit the root, that is D, and at the end we will visit the root of the tree, that is A. So here traversal is in which way? C, B, then you have F, E, then G, D and A. And in-order traversal is the third type of traversal, where you first go to the left branch, then root and then right. So let's go to the left side. Who is my root? A. Go to the left of root, that is B. B's left is C. So first traverse C, then come B, because it does not have any right. So go back A. Fine. So A, C, B, A. Now go to the right hand side of the root. Right hand side is D, but again it has a left branch, that is E. E does not have any left branch, so E will be traversed. Then since because E is a root, right? Then go to the right of the E, that is F. Okay. Then come back to D. The D is the root of E, sixth element. Then go to the right hand side of your D subtree, that is 7, right? So the traversal is in which form? C, B, A, then E, F, then D and G. So these are the three ways by which we can traverse through a binary tree. Now there is another variation of a binary tree which is called as a binary search tree. Now in case of a binary tree, we have seen that binary tree stores the element in left and right. That is, maximum it can have 2 child nodes, 0, 1 or 2 nodes, right? But binary search tree will store the same binary tree in a sorted order, so that the searching will become very easier. The sorting is done in the ways that left side of the subtree, where the values of the left tree is always less than the root element, and the right is always greater than the root element. So every subtree of a binary search tree will again be a binary search tree, means the subtrees are also stored in a sorted order, and the traversal here is done in an in-order way, so that you can get a sorted output. Let's consider this binary tree. It is, first of all, see, binary search trees are binary trees, okay, they are not different. But the difference between binary tree and binary search tree is that, okay, binary trees will not store the elements in a sorted order, whereas binary search tree stores the elements in a sorted order. Left subtree values are always less than the root and right is always greater than the root, right? So here if I want to perform an in order traversal, so what is in order traversal? Left, root and right. So first what is the root element? 26. Go to the left of root, that is 19. So you can see 19 is smaller than 26. That is why it is on the left side. Whereas 29 is greater than 26, so it is on the right side. Now again you see the next subtree, 19. The left element is 11. 11 is smaller than 19. So it is on the left side and 23 is greater than 19. Similarly, you can see they are in a sorted order. So now first thing what we will go, traversal, in order traversal will be 26 ka left is 19, 19's left is 11, okay. Does 11 has any left branch? No, okay. So what is the in order traversal? Left, root and right. So root is 11, so first element we will write is 11. Root is done, so go to right. Right is 13. So 13 is the next element. Again go back to the root of 11, that is 19, third element. Now go to the right side of 19. So right side of 19 is 23, fine, but 23 also has a left branch, that is 21. 21 again has a left branch, that is 20. So all the left will be traversed first. So 20 will be first one, that is fourth element. Then come to the root of 20, that is 21. Then go to the right of 21, that is 22. Okay. Now again go back, that is the root of 21 is 23. Now go back to the root of the tree, that is 26. Now left side of the tree is traversed. The root node of the tree is traversed. Now come to the right hand side. Now in right hand side you have 29. 29 has a left branch. So that will be traversed first, that is 27. Then comes the root element 29. Then go to the right side of the root, that is 33. Right of 33 does not have any left branch, so skip it. Go to the root, that is 11, that is the 11th element, and then go to the rightmost value of 33, that is 12. So if you see the elements, that is 11, 13, 19, 20, 21, 22, 23, 26, 27, 29, 33 and 35, they are stored in a sorted order. Understood? So if you traverse through a binary search tree, the elements will be in a sorted order. Even if you check for every subtree, okay, like 21, 21 is root of 20 and 22. Now 20 is smaller than 21, so it is on the left hand side. 22 is greater than 21, so it is on the right hand side. So in a case of a binary search tree, always the smaller values or less values than the root are on the left side and greater are on the right hand side. So that's all about the binary search trees. We will study one more variation of binary search tree, that is the AVL trees, and we will check the rotations, how to perform the rotations in AVL trees in my next video. So please don't forget to like, share and subscribe to CSE Core Concepts. Thank you.